All right. I think everybody online can see us, and we have some friends in person, a pretty good group in person. I haven't had an in-person group like this in some time, I would have to say. Let me say, first of all, you may have seen that Rhiannon Iha was going to deliver this presentation, and I am not Rhiannon Iha. In fact, I've never delivered this presentation before, so please bear with me, although I did work with Rhiannon to develop it. So hopefully all is well. So I'll do my best, and I encourage you all to engage if you have. I know there are a few experts in the room as well as people who aren't as expert, but anybody in the room who has, something they'd like to add, or like there's a resource they'd like people to know about, I encourage you to speak up. And that's true for you online friends as well, even though I'm going to do my very, very best to watch the chat. But I might be not as quickly, and I might not respond as quickly as you post, just because I'll have to make sure I'm seeing everything. Ryan, Harper, either of you able to join the Zoom so that you could tell me when there's a chat? Thank you. And I want to just note that as we go through the presentation, at any point, if you want to get the slides, this QR code here in the corner is for the slides, and it will be on every slide except when we leave this front slide, it'll be up in the right-hand corner. There'll be a few other QR codes along the way, and I'll just make sure to distinguish between them as we go. I'm Jennifer Moore. I am the head of data services, and thank you and welcome to Love Data Week. I do not have my beautiful Love Data slide because I, again, am emergency doing this presentation, so I didn't get a chance to add it. But I did want to introduce you to the data services team. We're located here in Olin Library and on this very floor. I'm the head of data services. We have several very expert people on our team, including Harper Tooch, who's in the back, our 3D visualization specialist. And Ryan, where are you on this slide? You're not on this slide, but you will be next time. And Ryan is our GIS and data science librarian and data curator. We also have Molly Webb, our geospatial programs manager and GIS developer. Sarah Swans is our data curator and digital humanities librarian. And Zach Shaponiak is our data curator and GIS librarian. And then we have a brand new, starting next week, data management and sharing specialist, Aviana Wooten, who will be doing workshops like this for you in the future. So we have 6 core service areas that we cover in data services. 3D AR/VR, again, that's Harper's domain. Data exploration and visualization is our fancy way of saying working with data, because although we know a lot of data tools, we don't necessarily know every kind of analysis, so we're shy about calling it analysis, but we can help you use tools to work with data and visualize data and get you where you want to go with your own, particular research question. Data management and sharing, we provide consultation on best practices for data management and sharing. We provide consultation for writing a data management plan. We do that for the Danforth campus. My colleague Sun Young, who's here, manages that on the Becker campus. Both of our campuses run repositories, so we can either help you deposit into our repositories or help you find a repository that is right for your data outside of that. And that is another workshop for another day, but I just wanted to mention it's a thing. Data sourcing is, or data literacy, it's the being able to find, evaluate, and understand data. Digital humanities is a very broad scope of things that we help people with, which could be any of these other services that I've talked about, or it could be something like text mining a large corpora. So again, another topic for another day. And our flagship service, Geographic Information Systems, this was our first service in data services and what we were built on and then expanded from. And so we support people using geospatial data in a variety of ways. We have several tiers of service that we support people in, which include our enterprise service, which is what we do the most of, and that is to give consultation and instruction and support for people who are doing their own data related projects. If we're not the right person, you come to us and for that kind of help, and you realize we're not really, or we realize we're not really the right person or the right group for you, we will send you on to other groups. We also have a recharge service, which is when researchers come to us and say, please do the work for me and hand me my deliverable. So that is generally grant funded projects. And we do considerably less of that than of our top tier, our enterprise tier. We also do one sprint a year, which is an app we do by application. So people apply so that we can do what we do in the recharge service, but for free. And we only do one a year, and that's why people have to apply. So that's the thing. If you need something done and you don't have any money, you can apply for our sprint. And then we also partner on grants, which is the thing we can do the least of, really. So we also provide instruction. This is a part of Love Data Week. I hope you all know about the Love Data Week events. If not, I'm sure Sun Young will write the URL up on the board. So we all know where, you don't have to really. I was just kidding.
I'm not online, so I can't.
That's okay. And we also do a series for Geography Awareness Week. We have an ongoing series called Data Savvy, which is an online asynchronous Canvas self-paced micro-credentialed set of foundational courses. So these courses are set up for people who have little to no experience with data to help them kind of get the lay of the land so that they can go into courses and feel more confident. And then this is, aside from being a Love Data Week presentation, this is also a part of our Data Lab series, which we collaborate with other entities on campus to provide data-related instruction. All right. We have several spaces that we would like you to know about. The most new and exciting one is AVA, which is our audio visual virtual reality and augmented reality studio, which you can reserve with the big QR code here, not the little one. Remember, the little one's for the slides, but the big is for AVA. And then we also have a research studio where people can come in and use specialized software that they need to do a project that they may not have on their own. So that might be, and that can be because it's an expensive software or because they have a Mac and the thing doesn't run on a Mac or what have you. And so you can use that physically in life, or you can remote into the research studio and use things like ArcGIS, SPSS, in vivo, whatever. Yes.
A quick question.
Yeah.
A couple slides ago, we talked about some of the things to do.
Uh-huh.
The next slide. Who are your major customers? Is it really just students and faculty? Or
Students, faculty,
administration?
sometimes administration.
Okay.
We work with facilities a lot. So we've done, for different, I couldn't even do justice to the list that we've worked with, but we do work with some administration, but it's not generally on institutional data, which I know is your area. But it's more on, well, sometimes it is, but often it's on things that are outside of the institutional data landscape. But like, for example, if they want to, I know in the past we've done mapping for like where are our students coming from for different offices. the registrar, I think, and things like that. But I would say of all the administrative groups that we work the most with, facilities would be the biggest. And I'm gonna shout out to Molly Webb in case she wants to type anything in that she feels is relevant to say. But yeah, mostly our audience are faculty, students, and people doing research on campus.
Thank
Excuse me, Jennifer. Hi.
Okay, we also provide a help desk 4 days a week. So Monday to Thursday, we have 2-hour slots where you can drop in, and you can do that in person in our office, or you can drop in via Zoom. And you know, as our team expands, we may think about another day, but right now we have 4 days a week for 2 hours a day. But you can also do appointments, which is why actually there's this QR code for request a consultation, because we know our help desk hours aren't going to fit everybody, but if you have a specific time you'd like to meet, we can
He can't
hook you up
access
with
his
the right
voicemail
person
because
at
it
the right
says it's
time.
restricted for some reason. Are you available to quickly jump on the huddle call? The huddle
I
call.
guess I can't hear the people
link?
on Zoom, Molly.
Cool,
Let's
thank you.
see
Let him know. Let's
if
jump
I
on the huddle
can
call
change
then.
that. Can you say something, Molly?
Can you hear me now?
Okay, let me try again. Can you say something, Molly?
Hello, hello, hello.
Okay, I can hear you now.
Okay.
Now, if you are not me or someone specifically asking a question, can you please mute yourself? But now we can hear our Zoom friends.
Okay, great. And Jennifer, if you'd like to make me a co-host, I'm happy to help manage the Zoom participants here
Oh,
on
yes.
my end.
Much, thank you.
Thank you.
Molly, did you have anything to add on the institutional data question?
No, I think you covered it, but yeah, we do work with a variety of different institutional clients as well.
Okay,
Great, thank you.
yep, thank you. All right. We're almost done talking about me. No. Well, at least my team. So today we're going to talk, we're going to go a little more in depth about the process of doing documentation. You know, in a lot of our sessions, we talk about the importance of documentation, but a lot of us have not learned to do it or even learned why we should do it. So this is going to go a little bit deeper. And again, I welcome engagement from the audience if you have thoughts or questions on anything I present. So we're going to talk about why we're going to do it, the best practices and tools for documentation. And then the end of this, well, not the end, but the second part of the session will be an opportunity for you to pull out a data set and use some of the tools and work with other people to do documentation on your own data. So we called this fair or foul, and many of you have probably heard of the FAIR principles, which we'll talk about probably all along the way, but definitely a little bit later in the metadata section. FOUL you may not have heard of as an acronym because we made it up. But we like to think of it as the opposite of fair, which is faulty, obsolete, unlicensed, and lost. Fair, if you haven't heard of it, means that data should be findable, accessible, interoperable, and reusable. And that's what a big part of that is documentation. And I am, if you have ever met me before, or if you've ever heard me talk about data management, I am a great big Kristen Briney fangirl. I really think that everything she's ever said about data management is right. So I thought I'd add this quote from her. She said, when people ask me how they can manage their data better, one of my top answers is by improving their documentation. In many cases, it's not even worth keeping data without proper documentation. Who disagrees? Because let me tell you something. I have done this well, I haven't done this presentation, but I sat in with Rhiannon doing this presentation, and Rhiannon got the feedback that it's not true. We don't really need documentation to do our work. So let me hear you. Tell me, do we need documentation to do good data work? And if you're gonna say no, I'm gonna make you tell me why you think that's true. Oop, chat. All right. No, so nobody disagrees. We're all on, you're too scared to disagree at this point. I think the person said that we do this all the time. You know, like we do our work all the time and don't record documentation, and that's fine. And I guess they're thinking we do it one-off and we don't need to remember anything. But if you plan on using your data more than once at all, you know, that, at least me, I don't remember anything. So I need documentation, yes.
I've heard many reasons. I'm part of data governance here at Washington. I've heard many reasons for people not documenting data. One of them is people said, well, no one needs to use the data except for me and a couple other people. But because there's only a few of us that need to use the data, we really don't need to document it because we know all about the data and you don't need to know about it, or no one will ever need to know about it. But they're making a lot of assumptions there. I mean, who knows? Something could change, and next month somebody else might need to use that data. Or what if somebody isn't here someday? So anyway, that's another reason I've heard. I've also heard that reason too, that like, we do this all the time, or, you know, we all know the data, so no one really needs to, or again, they don't have the time or the resources, or it's, you know, just kind of an afterthought.
It's the laundry of data.
The laundry.
Yes.
I work at RGA, which is a big data company here in St. Louis. And one of the things we hear is that stale documentation is just as bad as no documentation.
That's
I think
fair.
Where we get a lot of apprehension is I don't want to like put all this work into it, and then if it just becomes stale in 3 weeks, and then like when you look at the time it takes to document versus time to deliver, it outweighs the value. And that's kind of,
Interesting.
at least how our actuaries think.
Yeah, that's interesting. I mean, I actually can appreciate that argument, but I also think if we're doing documentation well, where we're like, you know, milestoning when this documentation is from, it can still be really helpful, even if things have changed, because it can get you back to a point. But I hear that. Go on, Sun Young.
Documentation is important when you archive the data. So if it keeps changing, yes, live documents needed, but when you archive from the funder perspective, they want to deposit data into data repository. They need a really good documentation to allow others to interpret and reuse data. And that one is a fix. And if you have to make a change, then you need to create new version. So there's version control, but that's what we're talking about here. But documentation is not for others, it's for yourself too. Your memory is not good, to be honest. So you needed something to go back and, you know, help you remember what you did, how it was collected. So from the beginning, if it's a tabular data, start with the data dictionary, define the variables, what is the level value, all this stuff from the beginning. And then it help you down the line when you're ready to share the data in a data repository. That's what.
And just for the folks online, I'm going to kind of summarize what people have said in the room, because I just saw the very reasonable request that I repeat what people are saying. And a few people have talked, so I'm going to try to summarize quickly. So one person talked about how data documentation, if it's out of date, it's almost as bad as not having it. And so that's one reason people don't like to do it. And then another person was talking about how a team that works on the data a lot really know the data, and so they don't feel like it's really necessary to did you say something else with that?
I also said that, you know, there's some people that don't think anybody else is ever going to.
Oh, right.
The data, so why document? We all understand.
Yeah.
No one else.
So he was saying that sometimes people on our team might say, well, nobody outside of our team is going to use it. And so we all know it, so we don't need to document it. We know what's going on. That's another reason people have said it. And then my colleague Sun Young pointed out that you know, when you're putting it in a repository, you need that documentation. And if it changes, you just we use versioning to update it. And but also we need it for ourselves to, like, you know, come back to our own data again. Did I get all of yours? In a nutshell.
For others to understand and reuse the data, that's what documentation. So it's like archiving purpose when you decide to do it.
Right, for archiving, yes. It's also good if you leave a team in a job, yes, for continuity, right? Like, you got one person who knows everything leaves. And then you know, a lot of institutional knowledge or knowledge about a project leaves with them. Yes, yes, and yes. All right, I'm gonna try to,
You know, at least you have to give them a head start. Right?
yeah, exactly, right.
That there's a baseline knowledge.
It
that
provides them
helps them.
context, yes. What are we even doing here? Right.
That's why we set the spreadsheet up in this way, or.
Yeah, I mean, we actually are working on a project right now that was originally done by people over 15 years ago. And we don't understand their file naming convention. And we don't really know how to know, you know what I mean?
Especially if they use the acronym without any explanation what exactly.
Right, like wherever the documentation is, it's not helping us understand.
Right.
Like what, and that's fine if you can, well, it's not fine, but it's, you know, sometimes you can like figure it out, but in this case, there's something missing that we are not able to,
Actually, speaking of file naming convention, like a lot of times we don't understand how the file was named, but Christine Greeny has a really nice worksheet for file. naming
yes,
conventions. So you can
she
just
does. She has
use
a
that
great
to
workbook.
create that.
I might have added that to the resources if I had been better prepared for today, but I didn't. But if anybody wants to drop the Kristen Briney workbook into the chat here, we will make sure that in-person people get it. Hello.
When it comes to those explanations for how decisions are made, I am, a baby when it comes to data
Uh-huh.
on this level. So is there a document? So sort of like, I know I keep hearing the phrase code book and we're talking. about
Oh,
all
you
kinds
are
of
just,
things.
you're gonna love everything that's in this presentation. Yeah, no, that we'll talk about the different ways, different disciplines document data. And so the person in the audience, was asking whether we would talk about ways to document because she's new to data and doesn't really have an understanding of how that works. So that is what we're talking about today. So with that, I'll move on from my Kristen Briney slide. But so didn't she just really bring it out of us, like the passion for data documentation? So why do we do it? I feel like we've been talking all this time about why we do it, but data needs context to be understood. So context meaning the description of the data itself, but the why it was done, why the decisions were made. It also, I mean, I don't remember what setting I put my toaster oven on this morning, so I definitely need it to remember things. And I think that's true for many of us. Again, if there are people who will reuse or collaborate, it's not even reusing really. If you're working on a team with people and you're you know, you have to use the same resources, having documentation to understand what each other are doing is also useful. And it can help prevent redundancy of data creation because you have good documentation of what was created and when, and you know what everything means. And it also makes your research more credible because you can point to your documentation and say, this is what we did. So if you're getting different results, then you did something that we didn't do. So that there are many, many good reasons. some of which I think have already been said by some of you. Thank you for the Kristen Briney workbook, Harper. And I'll send that out to everybody after as well. So obviously you are the first person who's going to benefit from your documentation. And if you wanted to put a semicolon behind that, you could put your team or number two, the people who work on your project, people who take over the work for the continuity, people who find your data in a repository, or people who audit data to make sure that you have done replicable or reproducible, or at least like a project that has integrity. So this is at a high level what we mean by documentation, but we're going to go more deeply into all of these things. So we're talking about who performed the work, what was done, when it was done, where it was done, and when might mean there are versions, as Sun Young was talking about, where it was performed, what was the purpose of the data collection, and how it was collected and also changed. So we're going to start into best practices, and I like to lead into anytime I can lead in with persistent identifiers, I try to, because persistent identifiers in our documentation are key to making sure that our objects in our data collection are findable and connected to the things they belong to. And I like this this particular visualization of having the object, the DOI of a data set in the center of this ecosystem, and then everything else can connect to that data. So it might be the published results that are going into a journal or wherever they're going. It might be connecting to the institution that funded the data. So there, an ROR stands for Research Organization Registry. So most research organizations have a number from this registry. And so if we document that, we can make sure we connect back to our institution. Let me tell you what happens when we don't use our ROR. We can write WashU, Washington University in St. Louis, Woostle, WUSM. And even though we are all a connected thing, we seem like different places. But if we use our ROR, we connect back as the same institution. A funder URI, so that our funder stays connected, where this money come from, and an ORC ID for all the contributors on a data set. Who in here has an ORC ID? Uh-oh. You need to get an ORC ID if you're gonna publish anything, so that you can connect your data to the work you're doing, and people can see the data that you work on. And I have, Harper, can you see what the question in the chat is? I saw a hand go up. Maybe they need to talk, actually. Do you want to say something in the? I thought I saw a hand.
I think they were just raising their hand to indicate they had an ORCID.
Oh, right, of course. Of course they were. I'm sorry, online people. Thank you for responding. If you don't have an ORC today, you should, or ORC ID today, you should get one. The institution recommends it. And even if like you're not, I mean, anywhere that if you're gonna save data and you want people to be able to identify who you are and what you're connected to, having an ORC ID is an important thing to have. Okay. So what we like to see these persistent identifiers inside of our documentation. So there are different types of documentation. So we were talking a little bit before about active documentation. So why do I need to do this? It's just my team. We're not going to publish it. But active documentation is good for the team. And it can consist of things like the raw data that you collected in the field or what have you. It can consist of code that you wrote to work with the data. It can consist of experimental results that resulted from that code, or it can be the protocols and methods that you're using in the collection. When you're publishing data in a repository like Sun Young was talking about, we're often, what we like to see are curated data sets so that they're in the best shape they can be to be published. And that, and they're you know, they're connected to an article or publication, and also with those protocols and methods. And so what the kinds of things that we use to document are README files, and we're going to go through these one by one. So you can ask a question now, or you can wait for the big reveal. Data dictionaries, code books, metadata, and protocols and methods. And there may be something that is not here, but these are the ones we're talking about today. And so if you think that there's some really important way to document, and I know, you know, aside from maybe within the code or something that you want to point out, please do. But these are the ones that I am going to talk about. So ideally, a lot of people think about this documentation when they're at the end of the project and they have to share it with somebody else. But ideally, we're doing this throughout our project so that we're collecting all those heat of the moment decisions that happen. And we know, you know, no parameter is lost, no, you know, choice or no structure is lost, because we have set it up before we started the project and we're maintaining it as we go through the project. And by maintaining it as we go, hopefully that will somewhat address the idea of it going out of style, you know, or going out of date as much as we can. And I know it's not the most exciting part of the data. Like there really are those heat of the moment things that are happening. You're excited about something, you've made some kind of breakthrough, and you have to stop and document it. What? So there are tools that can help you do some sidecar documentation, which we'll talk about in a minute, but it's worth it to you, especially if that breakthrough was really like as good as you think it was. Like documenting how you got there is so important. So again, we'll talk about lab notebooks as a type of documentation. Again, methods and protocols, README files, code books, metadata, and embedded metadata or sidecar metadata. So first for lab notebooks, and I will be honest with you, I don't use lab notebooks a lot myself, but I know there are people in the room who do. So, you know, anything you want to add here, again, I appreciate. This is a commonly used tool in the sciences, and really lab notebooks go back forever. Did someone have something online? Okay. If you are not intending to speak, please mute yourself. Lab notebooks used to be paper documents, right? And people literally took, and sometimes still are actually, take them to the field and they draw and they write and they, you know, do iterations and they exist like that. And that might still be happening, but they can also be in electronic format. And sometimes when we're doing things in a lot electronic format, we are not as good at like actually preserving the process because we just change things as they go. But lab notebooks help set us up to better record the process of the work. And it also sets us up to collaborate with our team members. So some important things that you see in lab notebooks are like entry dates and being able to organize parts of the project. So it can even include like analyses within the lab notebook, I believe, but also a connection to the data. And only the people who are on the team are connecting to that data. So it's a secure environment to kind of work with one another and also document what you're doing it as you do it. Anybody here work with lab notebooks? You want to say a little something?
Yes, so I work in the wet labs. I can give you some perspective from a researcher.
Can you do it like in chunks so I can repeat it to the people
Sure.
online?
So, in old days, we have a paper notebook,
Uh-huh.
but then, there's a written by, the author, and there's a review by as a second person who reviews the proof. The reason for it, because if you want to file a patent, for example, this is the underlying data, and then actual date, date when, the reviewer reviewed, that's the official date.
Okay,
So
pause.
that's one chunk.
Okay, so Sun Young's telling us about, modeling after the time of paper lab notebooks. There would be the researcher who filled in the notebooks, and then there would be the reviewer who reviewed the notebook on a particular date so that the researcher could get a patent because their data had been, their research had been reviewed.
Yeah, and then that's the underlying data supporting the patent, and then that's the date of invention.
So that makes it the date of invention.
But nowadays, we have an electronic lab notebook and Washer as a lab archive. And it's much better than paper notebook because now you can copy images into it, or
Mhm.
import protocols from protocols.io and put URL in there. You can record there, and everything is auditable, traceable. So it's a much better system, and it's available at no charge to Washer people.
So Sun Young's talking about how now that we have electronic lab notebooks like lab archives, we can put in images and
Video.
analysis and videos and protocols and
URLs.
connected data sets and that everything is what did you say?
Auditable.
Auditable,
Yeah.
Able.
With timestamp, there's a timestamp.
With a
of when it was
timestamp.
recorded. So that actually supports, I keep having automatically.
Uh-huh.
The timestamp of everything recorded.
Right. So there's a timestamp of everything recorded, so it makes it very transparent. Now, I will say that we don't generally share lab notebooks as a part of sharing research data. That's actually something that the OSTP pointed out as a separate thing that they don't expect to be shared. But that some elements that are being, sort of combined in the lab notebook, you could separate out and share. Are you agree?
Yeah, you can collaborate. So let the NIH name as a policy requires a findings, so like conclusive findings. So these are considered preliminary results.
Right.
It has to process and they kind of have some conclusion.
But it's not considered scientific research data. It's like a tool for scientific research data, and you pull the things out of it.
Yes, I mean, the definition of scientific data is findings that enable validation and stuff like that. But this lab notebook is a piece of things that might, come to a conclusion. So in any preliminary results are not required to share. It has to be kind of processed and conclusion kind of. That's what the sharing requirement is about in a repository.
So again, the key things that lab notebooks allow for are these data entries and organized, clearly defined elements, project summaries. Again, the elements and abbreviations are defined. All the contributors are listed, hopefully with unique identifiers, and this schema is described. And there is and content is indexed, so it's easy for people to work through. So this is, Sun Young was just talking about lab archives. So this is an example of using lab archives for your documentation and project. And lab archives specifically has developed itself so that as you're creating things, you can create documentation easily. So this is an example of this compound here and its result, as well as a description of what the result is. This is the index on the left. And then we see the name and dated entry here, like Sun Young was talking about with paper notebooks. We have something similar here that Lab Archives provides. This is a raw data graph. And then these things can be connected with the methodology, the data, and the final results. So I don't know if everybody online heard it, but this is a tool that WashU subscribes to for the whole university. So you have access to this with your Woostel key if you care to use Lab Archives. You can, another tool that works similarly that's open source. It has a slight, it's also for sharing data in another way, is the Open Science Framework. People choose these different tools for different reasons. I am inviting you to explore them and decide for yourself what works for you. Okay, so now we are going to talk about methods and protocols. So this is again very important in the sciences. Often, like especially if you're doing like human research data, you have to have a protocol at the beginning of your research that you submit to the IRB so that they understand what the research is and how it will be conducted. And there are many, many pieces to that. So documenting your protocols, good for all projects, very important for human subject related projects. So it connects both your correspondence, how you're using the data, the tools you're using, the data you're collecting in great detail. And it can also be curated and reviewed as the lab notebooks can. One of the really key things about protocols is registering a version at the beginning. And this is also something that you can do with the Open Science Framework. It's saying like, I'm registering my hypothesis. This is what my research is and what I think it's going to do. And that increases the transparency of data that you produce and the results you produce because you can reference that registration. You can also reference versions of your results. So this is a piece, this is a part of documentation. And so often when we're submitting a data set into a repository, we ask that people submit their protocol along with it. And we have a great tool, which I know Sun Young will want to talk about as well, called protocols.io, that is sort of like Lab Archives, but for protocols. Every protocol has a unique identifier that you can connect, like we looked at that model before, to collect all the data, connect to the data and to the final results and et cetera. Again, this is not something I use often. So Sun Young, I'm so glad you're here. I'm gonna offer you the opportunity to say something more about protocols.
Sure, thanks. So this is the documentation of your method.
Documentation of your methods.
Exactly. And then, so you can run record, which means it's actually integrated with the Lab Archive. So if you publish your protocol and you don't have to publish, I highly recommend you to publish, then you get a DOI. When you write a manuscript, you can just cite the DOI and you kind of archive the method you use for that particular manuscript. And let's say down the line, down the road, you revise, improve the method, then you create a separate version from there. So when people click on the DOI on the manuscript publication, you will see, hey, there's a new version available. You like to see it. So not only they get to see the version they use for the particular publication, they get to see the newer version tied to that one. So it's a really good way to document your method, not for others, but within your lab. Like we talked about, continuation when people leave all the time. So how do we know how they conducted the experiment? So by document, it's really basically like a step by step. It's so good. So I highly recommend to use it. Once you buy the premium license, you have unlimited,
Can you pause
access.
just for a second?
Okay.
So Sun Young is telling us about how great it is to be able to create the documentation and then publish it to get that DOI. And then when things change in your research or you've made some kind of advancement, you need to update your documentation, you get a new version connected to that DOI.
Right, so yeah, so for methods, so it's a protocol, and then it can run record of it, and it gives you, it allows others to cite your method. So this is the research output. Consider the research output, you can put it into your CV or, bibliography. So and when people actually, copy yours, fork it, and then it will give you credit automatically. It's tied to the protocol in a way. So in many ways, great way to document your protocol and method and get the credit you deserve, and then keep track of the changes you make along the way.
So for the people in the room who maybe aren't seeing everything, we also have research quals, which does modularly publishing. That's another tough set of letters to put together into a word, and often also open biz. And I'm going to save this chat at the end, and I will share all of these great resources with everyone at the end. And then someone's mentioning a statistical analyst plan or a SAP. Where would be a good place to save this for a project? I mean, minimally, if you package that with your outputs, not knowing what it is, but generally when we're talking about packaging up the data that we're going to share or what have you, we would package something like that with the outputs.
So actually, the one more thing about Purpose.io. So I mean, I did like a 3 separate webinars about this one. You can find it on our website. But if you have a written document about your method, Purpose.io has a free import service. You upload the document in PDF or Word, they convert it to Purpose.io format. And all you have to do is review and make some changes and then publish it. It makes it very easy for you to do that.
So Sun Young's talking about being able to upload like a Word document to protocols.io that you've just like outlined what your protocol is, and then you can upload it and it will change it into it'll like transform it into a protocol within the system that can be published, and you can get a DOI for it. Can you use the platform just to describe the manual procedures? Yes, is what I want to say.
Yeah, you don't have to publish, and it's a great way to collaborate with internal or external collaborators. You can give them the access and they kind of work on the procedure together. There are multiple ways to use the Purpose.io, and I highly recommend to watch the webinars.
Yeah, so you don't have to publish your protocol. You can just, create it and use it for your team, and it can be your team's manual of procedures. So Sun Young's recommending the documentation provided for using it user-friendly, I suppose, and yeah.
Yes, I wrote a blog about it and also had 3 separate webinars. If you go to backofdms.usu.edu, go to events section, and under data management, sharing there like 3 sessions with those slides and recordings.
So Sun Young has done a deep dive into protocols.io, and those sessions are recorded, and I can link those after the session as well and send them out with the email in the references. All right. We're just scooting along here, not moving super fast. I might need to pick up the pace a little bit. So yeah, this is Rhiannon is just pointing out here where we can see the digital object identifier, that there are different tabs available within protocols.io that show the steps and the metadata and the materials and the metrics separately. You have context in the description, and then the methods, the step-by-step part are this box here where it says part 1 quality control. And the materials, this is from the materials tab. So we're seeing all the materials used in this experiment, including descriptions of their variables. And again, there are some simple things you can do. You can put your protocol into your README documentation. It's very simple. It's very portable. It doesn't require any kind of software. I don't know actually why protocols.io isn't listed here. Maybe because we just looked at it in depth. And you can provide the key information about the data and the project and the methods there. Open Science Framework is another good place. And if you are working with code, GitHub can be a great place also to store your methods and protocol. And often that's what you find in the README file of a GitHub repository. So when I talk about READMEs, I'm not actually talking about the GitHub README that you find when you first go into a repository. I am literally talking about a .txt file, which is about as simple of a format as we have. Maybe with its friend, the CSV, are two most simple formats. And so it lets you share your protocols, share your documentation in a very bare bones way, but a structured way, because if you use a standard template, you're finding the key information, the information that that's needed for a project, but in this simple method. When we archive data sets, we always include a README file in the package because of its portability and its did I get another question? Maybe not. Or was someone putting up their hand? I don't know. Maybe not. It was a false alarm. You can package it up in the README folder. I'm sorry, in the data folder, so that you have all of the things that are in the folder connected and how they were developed and used. Again, we recommend even in a basic README template or a basic README file that you're still including those things like unique identifiers so that objects can be reconnected. So these are the elements of in general of a README file template, and it's like the README file template that we use ourselves, and it includes author information, where like the very general stuff like when was this collected, where, who funded it, a basic description, and a related DOI. The sharing and access information is really important to have in a README file because it actually is a part of that fairness of understanding how you can reuse it because it has the license information. So if you find a data set out there that has a very restrictive license, you're not able to use it the same way as an open license. And knowing that at the outset might impact whether you decide to use a data set. So that is something we definitely want to see in the data. And then links to other data sets, provenance of where it came from, how it's changed, and citation information. A detailed file overview, so including the file and its description and how it's related to other files. And also another here, and this is something that you might pull from other documents, but a description of the process in the case that for whatever reason, someone gets a hold of this data and they want to use it and they really need the methods in this simple format so they don't have to rely on some other tool to understand what the data are and what they're doing. And then a variable description can be listed in the README file. You can connect this to other tools that you're using to describe the variables, but again, its power is its simplicity and its portability. So this is what a README file looks like. It's pretty basic. This screenshot might be a little bit, no, it's right. So like this is our README file. So we include WashU's research organization registry ID because we assume that someone that's depositing into our repository is from WashU because we don't really take anything if they're not. So we need we need WashU's registry ID. We also ask for each principal investigator or collaborator's org ID as well. In the funder section of our template, we try to record here, aside from the funder name, but the award number and the award URL. And then as you go through the other sections of our README, you fill in the variables and the methods and things as well. Again, if you have the slides, our README template is linked here, and it is for all disciplines, and it can be, modified as needed. So now we're going to talk about a data dictionary, and again, this is a description of the variables specifically of a data set. So this is something that would be part of a package of documentation. And you might list it in your README file, but it's great if you can also have a table of this as well. It makes it for very easy use and for searching. So it's most useful for tabular data where you're naming variables. You're observing something and you're naming and you have variables and you need to describe what those variables are. And describing what variables are means describing the meaning, the units and their format, expected values and known issues. So to talk about that a little more with examples, if you look at this data dictionary, we often have in our tables short, often abbreviated headers because they need to be so that they can be used in the tools we want to analyze them with. So sometimes it might be clear what those variables are, though we should never assume. But sometimes it isn't. So like I probably would guess that DOB is date of birth, but it might not be. Funny story, we talk about DOIs in our world all the time, right? Upstairs, we have a Declaration of Independence that our special collections people call the DOI all the time. And I'm just like, please stop calling it that. But that's something that could happen in this situation, right? Like, DOB could be something else and we could assume that it's date of birth. But if we have a data dictionary, we have a description of what it actually is and the kind of variable it is. So this one says date. I would like to ask you to not look at the format of this date because it's not actually the international standard, which is 2-character month, 2-character day, 4-character year. But anyway, saying that this is what you would expect to see here is a date and the format it's in is useful. And then the kinds of values you might expect. I might actually put the kind of values I would expect into this. Like in this case, I might have put that here instead of here. But you get the point. And the reason to show the kind of values you want to expect. Why do you think we might want to show that? Anybody? Because if I want, for example, my expected values are 1 through 5, and I get 23, what does that mean to me? What might that mean to me?
Aggregation.
It can be an entry error, it can be some kind of aggregation misstep, it could be some kind of outlier, but it's different. It's not an expected value. Formatting could be wrong. Yeah, there, it means, look at me, I'm weird. So, and then you can figure out why. Okay. Yeah.
Like especially date,
Right,
you give you weird number.
right. Yeah, it changes dates all the time. Oh my gosh.
Back to the ISO 86 or date, the date format. You know,
Right.
4 digits of year,
Yeah.
2 digits of month, 2 digits of date, so it's the problem.
Yeah. Yes. Oh, sorry, before you ask, Sun Young was just pointing out that Excel often changes our dates in columns, even if we have it, formatted the way we want, and that it hasn't yet adopted ISO 8601, which is the international standard for dates, which is again 2-character month, 2-character day, 4-character year. Say it again, one more time for the people in the back.
It starts with year first, 4 digits.
Right,
of
you're right,
year,
it does.
followed by either hyphen or no hyphen.
You're right, it does
2
go the
digits
other
for
way.
month, 2 digits for-
All right, and what were you gonna say?
This question, this kind of goes with more structured data, like how do you guys document more?
Like, give me an example.
Like we have a lot where we are capturing like JSON.
Mhm.
Essentially from websites and things like that we then find, like how would you?
But JSON is still like creating a little like a little package, a little object package, right? So I would say, I mean, I think it is, I don't know, like, if there's an easy automated way, and I'm gonna, shout out to Molly Webb if she wants to, because she's our automation person, if she wants to say how to do that, but I would still make an effort to describe whatever that object is called in the JSON description, I would have that in a data dictionary.
Yeah.
I mean, and do other people have other thoughts about how to do JSON? Automator, do you have any thoughts?
Mhm. Um, with JSON, you're still going to have key value pairs that will need to be defined.
Exactly.
So I would argue that you would still need a data dictionary.
Yeah. Thank you, Molly Webb.
Sure thing.
Okay, so in the resources that are at the end of the slide deck, there's a data dictionary creator application, which you can try out and see how it works, and look, it works with JSON, so that's exciting. You can let us know how it goes. I can't seem to use this properly. Okay, so code books are largely used in the social sciences, and they're similar to data dictionaries, is where you're describing elements of the research. So it includes the code name and a full definition. They are often, they go a bit deeper than just a variable, but going into some more nuanced descriptions. And they should be created for any new data set. So if you are doing work in social work or sociology or anthropology, this might be a way to go beyond variable descriptions to provide a more nuanced look at the data set. And this is what it looks like. So here where it's showing us the code that they use to describe something and its description, and then an example of its use. So a few different tools, like for example, if you're already using a tool like Atlas TI or in Vivo, you can create code books that you can upload into your into the software, and so that you have the things you want to tag with described because you're tagging in Vivo, and then you can apply that as you go through using the software. Code R has a tool called Codebook R that helps you create a code book from your R code. And also DDI stands for the Data Documentation Initiative. And it is the most commonly used metadata standard for social science research. So this is our DDI is a tool that specifically will create a code book in the DDI metadata standard. Okay, so now I've used the word metadata a lot. Am I amongst friends? Do people know the word metadata? Yeah, everybody knows. So yeah, metadata is like the great big F in FAIR. It's the key to making things findable. And there are different kinds of metadata. And the metadata I'm going to talk about first are just metadata that we use to find. So the schema I'm going to specifically talk about is the data site metadata schema, because that is what we use in our repository to make sure data objects stay connected. And some key elements that are needed are an object identifier, creator identifier, so that orc ID, affiliation subproperties, so that ROR, title of the object, who published it, and like if you're publishing in a repository, they are the publisher. Like even though we think of publisher as more of a maybe journal kind of thing or book kind of thing, when you're publishing data, the repository is your publisher. When it was published and the kind of resource it is. This is the full data site mandatory, recommended, and optional information. And when we're evaluating for fairness in our repository, we're evaluating how much of this is, one of our evaluation points is how much of this is completed, because we want our data to be as findable as possible. So versioning is a really important piece, as is things like funding reference. And you might ask yourself, is there really a difference between recommended and optional? Aren't they both really optional, but one is like just we like it a little bit more? But I would just argue that all of these things, like you can't put it into a repository without these things. Okay, that's what mandatory means. But these things are really important too. And we should always collect as much as possible because it makes it more findable and more connectable to other things. So this is what a metadata schema looks like if you looked at it in like a XML reader. And so you can see it has a unique identifier here. Have our language tag, the title of the thing, the creator of the thing. We should really have like a orc ID for the creator of the thing. A subject, all of these in XML tags. So, again, just going back to FAIR, the metadata is a big part of Findable. It's also a part of Accessible, including having the identifiers. It's also very much a part of Reusable. And I want to just talk now a bit about metadata standards. So I talked really briefly and high level about the data we use to find research data, or the metadata standard we use to find research data, just data site. But different fields have different metadata standards that they use to describe data in depth. So to the extent, and I know we're already at the point where like, please, please, please just do some documentation. Like we just want people to do some. But if we use the standard from our discipline, then it makes our data more reusable by our colleagues. So it's a really good idea to use the standard from your discipline. So for example, Darwin Core is a really well-known standard for data in biology. We just talked about the data documentation initiative. So like social science research, you know, that standard actually, like I know DDI specifically really works to make the data and the metadata like combine together so that you have it as a sidecar so it can actually be useful for you in situ. So like if you learn and use these standards, it will make your data really more reusable. Now, I don't know all the metadata standards. I don't know if anybody does, probably, but I don't know what it would be like to talk to them. But there is a metadata standards catalog where you can find your metadata standard for your research area, and I really recommend that you do that. I want to talk just a little bit more about embedded or sidecar metadata. So I'm going to use images as my example for embedded data, but a lot of data types have embedded data. I work a lot with geospatial data, and there's sidecar data that comes with that type of data. But like embedded metadata, like when you take a picture with any camera, the camera is recording a ton of metadata. We don't often see it. Sometimes we see it now on our phones, actually. If you click on an image, it'll show you like where it was taken and when it was taken and stuff like that. That's all metadata. And you can actually export that metadata and even change that metadata if you wanted to. That's me, everybody. So if you are looking at this metadata here about this image, does anything, what do you think, if you didn't see the image, what would you understand about this image without seeing it? If you just looked at the metadata? I don't know how well you can see it in the room, because it's pretty small, isn't it?
Capture, what is the file format, location data,
So when was it captured, Sonia?
file accessing time, there's a modification time.
So
it's,
the earliest date is what?
the modification time, yeah, I would say
Do you believe it? No.
2008.
2018, really? I've aged a lot in the last years. So what would your guess be by looking at this metadata, just by that alone? Well, scanned, yes, Ryan Wallace, that's right. So this is a scanned image. This is not a digital image. Another guess might be that there probably weren't digital cameras this time, but yeah, no, so the metadata can tell us really good things, and there are tools we can use to export metadata and review it. But again, you can export it as a text file and modify it. And so if you're looking at embedded data that has been exported, you have to be, you know, cautious about whether it is also accurate.
the camera I got works for that specific LG, you would find that it works the internal camera for a scanner rather than a.
Yeah, I believe it. So, EXIF tool and this DICOM viewer are both, they both extract EXIF metadata that you can use, to, understand what kind of metadata has been collected about an image. Okay, oh my gosh, we made it to the end of the presentation. There are a bunch of tools in here. But before I let anybody, because I want you to stay and work on your own data sets. I really do, really want that. But I also thought I might give a little shout out to Barry to say a little something about Calibra, since we're talking about metadata, and he works in institutional metadata. I'm sorry, institutional data here at the university, and is very much in the know about Calibra. Barry, I'm gonna actually let you walk up here so I don't have to repeat everything
Sure.
to these people. So do you want to walk up so that they can hear you?
Thank you, Jennifer.
Yeah, no problem.
So if people aren't aware, hopefully everybody could hear me online. Jennifer, thank you for the opportunity. If people aren't aware, we have a tool at the university called Calibra. I don't know if anybody has heard of it. Okay, so I see some nods. That's great. And this tool is really to document what we're doing right here, essentially what we just kind of talked about, but more with institutional data, not necessarily a researcher's particular data, but data about the university. So you think of all of our facilities related data, all of our advancement data, all of our data about HR. And again, the stuff in Calibra is not necessarily protected or highly sensitive. It's mostly, again, metadata. So again, you might find out, for example, what a certain, what the different, I'm just trying to think of a good example here. You might find out what a certain supplier type is, but you might not know what suppliers are in that supplier type. Okay, we have different, vendor types at the university. You might find, sensitive information about, for example, salary types or salary grades and stuff like that. You won't know who is attached, to what salary grade or whatever. So again, it's all metadata, right? I'm speaking to people that understand metadata. But really, I encourage you to go to one.woostel.edu. Do you mind if I do that right here?
Please do it.
Oh, okay. Let's see here. Do you have a
You might have to just, yeah.
do you have a Chrome browser up or something?
Yeah.
Here we do. We do have a Chrome browser. Uh-oh.
It's behind me.
So yeah, so if you go to I should probably get my glasses. Oops. I don't know who uses one, but I find it a very useful. I use it all the time as well. Just like Jennifer said, I don't remember a lot of stuff. So, so if you go to one.woostel and you just type in Calibra, you should get the tile that says Calibra login. And I guess this is logged in as you, right?
Yeah.
Okay, and that's fine. Anybody with a Woostel key could access Calibra. You don't need to ask permission or anything. For some reason, it's asking for your login while you're doing that. And you can just log in it yourself. But anyways, this will help you understand the data that we have at WashU. So if you're looking at stuff in Workday, you're looking at stuff in some of the other systems that we have around campus, whether it's, sustainability or facilities or advancement or whatever system you might be looking at or whatever data you might be looking at, we have information about those. Just to show you right here, if you hit browse, we have information about advancement, facilities, finance. So all those finance terms, if you come across them, HR, which is HCM, innovation, a lot of stuff in research administration. I mean, we're talking a lot about research. There's a lot of stuff about research and administration in here. And how did we get all this in here? Well, we've worked with what you might call stewardship, our fancy way of saying people responsible for the data at WashU. So for research administration, we worked with people in research administration at the university to actually document the most important business terms, metrics, reports, things like that in here. So that's where all this came from. The Office of Data Governance didn't do this work per se. We worked with people to get this in here. So it's a really good tool to help understand WashU data. We also have an area for acronyms around the university as well. It's a great place to look for data related to Workday. If anybody has used Workday and tried to search for things in Workday, it's a pretty frustrating experience. It's much easier to search for things in Calibra that relate to Workday. So again, I didn't want to take a ton of time. It was very nice of Jennifer to allow me to plug this, but you know, check it out. We have all sorts of training in there and resources and so forth. And if anybody has any questions, feel free to ask me. I'd be more than happy to help. But you know, just a good resource to learn more about WashU data. Thank you so much. Appreciate it.
Thank you for
Yeah.
going off the cuff for me.
Oh, thank you.
Okay. All right, so now, what we're gonna do now is, we have a few templates, if you go to this, QR code, and you can use them to work on your own data documentation. We're gonna take some time to kind of do a little bit on your own, and then you're gonna spend, maybe we'll do 15 minutes looking at our own documentation, and then the rest of the time talking to our neighbor about it. If it sounds better to just talk to your neighbor about it first, we can just do that, because I don't know. What do you think? What do you want to do? How do we want to do it? And I'm ready to make breakout rooms online, people, so don't run away from me. Oops, let me go back. Okay, I'm gonna pair you. I'm gonna split it two up, I know. And you guys, and then you can. And you guys wanna be three? Oh, really? Okay. Yeah, you're welcome. There'll be a survey at the end for you to fill out, and yes, you